Hello, welcome back to another Chem 2C Chapter 11 video. We're still on cell potential, and this video I'm going to be talking about relating cell potential, the standard cell potential, to the standard Gibbs free energy. So Gibbs free energy is coming back just for a little bit in Chem 2C from the previous Chem. And if you remember from that Chem, the the Gibbs free energy, which is the delta G0 standard, it determines spontaneity. I'm just going to give a brief summary. Um, it determines if a reaction is spontaneous or not. And remember, if it's negative, it's spontaneous, and if it's positive, it's non-spontaneous. And when it comes to standard E, so when it comes to Ecell, it's the opposite. When E is so for a cell to be spontaneous, the total total standard potential has to be positive. While if it's non-spontaneous, if the cell potential is negative, that means it's non-spontaneous. So you see how these two are the opposites: spontaneous when negative, while this is non-spontaneous when negative, while this is non-spontaneous when positive, while the E is spontaneous when positive. And there's an equation that ties both of them together. Well, I'm going to talk about a couple key things before. So if you remember in the previous video, I talked about how if you multiplied an equation by 2, so remember I multiplied this equation by 2, in terms of calculating the standard the standard cell potential, then you change the moles of the elements that are being in the half reaction. It doesn't affect the standard cell potential at all. So if you multiply that as 2, 3, the standard potential stays the same. But then when it comes to the Gibbs free energy, so I'm gonna write this equation. When it comes to the Gibbs free energy, something like this: the Gibbs free energy is equal to N times the Gibbs free energy of the products minus N times the Gibbs free energy of the reactants. As you can see, in Gibbs free energy, the moles of the equation does matter, while in cell potential, the moles don't really matter. And I'm going to explain why by showing you the equation and how to convert one to the other. So the equation that relates Gibbs free energy to standard cell potential is this. And what each of these mean is, obviously, the delta G0 means standard Gibbs free energy. Then the N is, instead of the moles of the reaction, the N is actually the moles of the electrons, not the moles of the atoms, the moles of the electrons. Remember in a cell potential question, the electrons these are the electrons, and they can either have 1, 2, or they can have any number actually, but usually they have 1e, or you multiply by 2 to get 2e. And the moles of the electrons, what we're checking is after you multiply, when these two equations they can cancel each other out when they have the same amount of e. That's the moles of e you use. I'll explain further by showing an example. And the N is the moles of E. The F is something called a Faradays constant. Faradays constant. And the E is obviously the cell potential. And this Faradays constant, this is the charge in 1 mole of, so like I said, 1 mole of electrons over here, which is in the equation, this is the charge of 1 mole of electrons, which means the units are C over 1 per mole of electrons. And how this equation will work out is the units are, so delta G0 is equal to, the N has units of moles times E0. The F has units of C over moles of E naught, and the standard cell potential has units of volts. And if you remember in the previous video, I said volts are joules per coulomb. So we're going to primarily be using joules per coulomb because we can't cancel anything out with volts. Joules per coulomb. And if you cancel stuff out, so these two cancel out and then the coulombs cancel out, you're going to be left with joules as the unit of the standard Gibbs free energy, which makes sense. If you've done chem in the past, the Gibbs free energy usually has units of joules. So what I did right now was input the problem from the last video into this problem, and we're going to be finding the standard Gibbs free energy of what we found already. So how to do it is, first of all, looking at this equation right here, we found the standard cell potential of these two, so zinc and iron. We already found the standard cell potential from the previous video right here, which is Ecell is equal to 1.531 volts. And now the rest of the problem we can find, so the N, the moles of electrons, how we find that is we look at this equation, we look at both of them, and we figure out how many moles of electron was used when you join the two equations together, basically. And over here we have 2, over here we have 1. So which one do we use? We use the higher one usually. So right here, when you put both of them together, to get these electrons to cancel out, you have to multiply the iron by 2. You have to give coefficients of 2 to all of them, so you multiply the whole equation by 2, which now gives us, the iron now has 2 moles of electrons as well. So the moles of electrons in this is 2. We're using 2 moles of electrons. And now another variable in the equation, F, which is Faraday's number. That one we don't really find from the equation. It's usually given to us in an exam, and it's always going to be 96,485 coulombs over mole E. We don't have to remember this number as it will be given in an exam usually. So now we just plug it all in to find the Gibbs free energy. Do the negative of the N, which is the 2 moles of electrons, times Faraday's constant, which is 96,485 coulombs per mole of electrons, and then finally the Ecell, which is 1.531. And instead of using volts, like I said earlier, we use joules per coulombs, which is the same thing as volts. V is equal to J over C. So we use joules over coulombs so we can cancel out the coulombs. Joules over coulombs. And now we cancel stuff out. So moles E, cancel the units out. And you should be left with joules, and you just plug the rest into a calculator. And when you plug it into a calculator, you get a final answer of the Gibbs free energy is equal to negative 295,437 joules. And we can leave this in joules, or we can convert our answer to kilojoules by dividing by 1,000. And when you do that, you get 295 point. We can just ignore the point and just call it kilojoules. And that will be the Gibbs free energy. Negative. Forgot about the negative. Don't forget about the negative. That makes it important. And after this calculation, we can see that the Gibbs free energy here is a negative number, which means it's spontaneous. And it goes along with what we've been saying, where if it's negative, it's spontaneous. And when the Gibbs free is negative, always the E cell is going to be positive, always. And right here, of course, the E cell is positive, and it's also spontaneous. And that wraps up spontaneity and Gibbs free energy and cell potential.